Professor Gupta to join in. Yes. Good morning, everyone. We'll be starting in another a minute or so. We are waiting for our president to join in. If secretary allows us, we can start the meeting, whatever you think. Here it is raining heavily today since yesterday evening. So the connectivity may be little dicey, but hopefully we'll have a good session.
Here also it is.
Yeah. This place in Shillong, sir, in Shillong it is raining because of, as per the IMD's predictions also. So that way,
As per the IMD's predictions also.
Confirmation. They said that 21st, 22nd, and 23rd it will rain heavily. But 21st was a dry day. It didn't rain. But 21st evening, night time onwards, it started raining heavily.
Dr. Walia,
Mr. Walia, Bansal Saab is calling you.
he is busy on his landline.
No, I'm talking to the president only to get the permission to start because he'll take another 2 minutes to
That's
join
right.
in.
I think
So, yes, sir. You wanted to say, Bansal sir, you want to say something? You need to unmute and speak. Yeah. Hanji.
anyway, it's nice to see Dr. Gokhran after a long time, looking very charming.
Namaskar, sir. How are you? Yeah,
Fine,
not see. Yeah.
Thank you.
मुझे.
Yeah. So, respected council members of Geological Society of India, fellows of Geological Society of India, participants joining this program, these young and enthusiastic presenters, those who will be delivering oral and poster presentations. I welcome you all on the second day of National Seminar on Sedimentation, Tectonics and Metallogeny of Northeast India. Today, mostly for first half of the day, we will be discussing about the tectonics of Northeast India. While saying this, I just want to tell you that, inform you all, those who are present, that tonight or say early morning, yesterday night or today early morning, there was an earthquake of 4.5 magnitude around 40 kilometers from Guwahati, around west of Guwahati, at the similar place where 1897 great earthquake occurred. So on the eve, or say on that day, same day, we'll be discussing tectonics. So you can understand that understanding the tectonics, crustal dynamics is of great importance in the northeastern part of India. And in the present day scenario, when we discussed yesterday that this region has seen such a shortening of almost around 1,500 kilometers in the past 71 million years, and this zone makes the region more important. And for better understanding of the lithospheric dynamics, we must understand the tectonics of the region. So, without wasting much time, I would hand over the mic to Akule. She is the main organizer for this program, and to go ahead with the program, please.
Okay. A very warm welcome to everyone to our second technical session. So I thank Professor Walia for the brief introduction for today's technical session, Tectonics of Northeast India. So I invite, at the first outset, I want to invite the invited speaker for today, Dr. S.G. Gokhran from the Indian Institute of Geomagnetism, Navi, Mumbai. An eminent personality, elected member, International Commission on Middle Atmosphere, one of the commissions of the International Association of Meteorology and Atmospheric Science of the International Union of Geodesy and Geophysics, scientific discipline representative, Scientific Committee on Solar Terrestrial Physics, elected Life Fellow, Indian Geophysical Union, member of the Indian Screening Committee, scientific visitor, High Altitude Observatory, National Center for Atmospheric Research, Boulder, USA. He also has a scientific honors recipient of Professor Jesu Ratnam Prize for Proficiency in Physics and the Physics Research Laboratory Award in the discipline of Earth and Planetary Science for the year 2005. So we're very honored and privileged to have you in our midst. I now give the time to our sir to take the time. Thank you.
Dear participants, I would like to request you that don't share anything because we didn't stop. So, Professor Gokhran, please share, and you can unmute your mic while starting. So, in the meantime, you share. I would like to tell you that Professor Gokhran has got wide experience of working in the Northeast, although rest of India also. But today he'll be making presentation on tectonic fabric of Northeast India.
Hello.
You are audible.
I think I'm. You're seeing the slides
Yes.
also, right?
Yeah.
So I can start.
Have you share? You are sharing. You are switching on two of the. No, it's okay. Yeah, please. You can start.
ठीक है सर. Hello.
There is echo. We cannot hear correctly.
Hello. Hello. Hello, sir. Am I audible?
Can you hear? Can you hear?
वाले सब ठीक है, चालू कर दूं? आवाज वगैरह आ रहा है ना? अच्छा, आइए, ओके, आइए, तो शेयर करता हूँ. शायद से बात करें ना? आइए, अब ठीक है ना? आइए, ओके, आइए. So the initial disturbance. I was talking about the tectonic fabric of the northeast Indian region, and I think I'm heard by everybody. So basically, before I begin, I have to thank Dr. Walia for inviting me, and again I have to thank Dr. Khemraj Gupta, who was the main brain behind. Basically, he initiated me to the northeast region. And first survey we did in Mizoram, which you can see in this slide at the bottommost. And then subsequently we did different surveys which are marked in red. This is from Tawang. I hope you can see the marker also. This is from Tawang to Difu. There was a second profile, and there was a third profile from. This is Rangia, almost on at the Bhutan border to Dauki in the south of Shillong, passing through the Shillong city itself. So now, first I'll just talk about the Shillong plateau itself. This is a geological map, and this is a work already published. At the top, I have given the reference. It's in Geological Journal International 2008. Now, when I sort of talk about Shillong, one thing I notice is that there's a gravity map of Shillong. It says predominantly an east-west strike, showing that the sedimentary basins are east-west, but you can see a lot of strikes at different angle in the gravity. Like you can see a fault from say here. There's one fault here, and maybe there is some fault, and basically you can see a lot of different faults crisscrossing the entire region. So now, this is the same gravity map superimposed with the shallow earthquakes on the left side and the deep earthquakes on the right side. You'll see that practically there's not much of a match between the earthquakes, and like basically they are all scattered. You don't see much of a correlation between the seismic epicenters and the different fault lines you can draw through the gravity studies. This is always the case, and practically I have observed this all over northeast India, that practically any geophysical study you have, it shows very little match with other geophysical studies, and that's one of the main difficulties in studying the northeastern region. Now here I have shown the our studies from. Basically, this is the station 1 is Rangia on the north side. Actually, I'm talking about this profile. I think you can see this north-south profile running from Rangia at Assam border to Dauki in the south of Shillong Plateau. Now, in this, and here this you can see the profile plotted on the gravity map. Now, usually when I do the magnetotelluric surveys, which is my which was my bread and butter during my active career, I always try to study minimum geology before I start the work. For any other studies, I studied minimum, and I just wanted to know what I get from the MP studies. Now, as a result, like basically this is a profile obtained. Like I just knew the strike direction, and from the strike direction I used to get the overall structure. And then I compared with the other studies. Now, when I did the survey, or when I did the analysis of this profile from Daranga to Mauki, I could see the top sediments, which are obvious here, right up to somewhere near, this is Guwahati, somewhere near Guwahati, and at Guwahati there was a large gap because of the cultural noise. Like this point station number on the south of Guwahati, and station number 15 is almost about maybe 5 kilometers north of the airport. In between, we had a lot of stations, but whatever we covered was only the noise, so I'm not really included them here. The first feature you observe is the feature E, which is the conductive portion dipping from Dauki, that is station number 26, and going right up to depths of around 10 to 20 kilometers. It goes right up to the station 1, which is more or less Shillong, or a little somewhere a little north of Shillong. So this is basically, it does look like a thrust along which some very highly conductive sediments are subducting northwards below the Shillong plateau. Now this, the surface expression somewhere near the station 26 coincide with the east-west striking Dauki fault in that region. Now about Dauki fault itself, there are a lot of there is a lot of literature. Some of it says that Dauki fault is a thrust zone, whereas some of them they say it's a strike slip fault, and both have their own arguments. Like basically on the surface, you see, and I think it was Dr. Evans who has done the work, and he says that there are silicon sets observed in Dauki region, because of which he says that it may be a strike slip fault. But here we are seeing it as a thrust fault. Now, in fact, most of the literature is divided into two groups. One school of thought says that it's a strike slip fault, and the other school of thought says that it's a thrust fault. Now, other thing, you can see yeah. Here you can see a good deal of highly conductive material. The portion G has a resistivity of almost of the order of something like 10 ohm meters down to around something like 0.2 to 0.5 ohm meters. Now, what is this? And that it was a little confusing because I think I should have shown it with the gravity map. So I'll show it with the gravity map later. So it can be one of the sort of hot magma which is rising along the faults, or it could be some water. Usually, when there is a thrust fault on the beam, there is a lot of water rising along the thrust faults, and that water leads to the high conductivity along these thrust faults at deeper levels. Levels, resistivity depends. Like if it's so if there are sediments, they can be a little conductive. But if it's say both highly resistive rocks, you may not see any specific contrast unless it's caused by waters rising or waters and fluids rising along the thrust zones. So we'll see what is G later. This is this Brahmaputra fault, which is a north-tipping fault. It's seen as C, and at depth you can see, and basically the line joining C and H. And again, it has a surface exposure which is covered with sediment. So now the third interesting feature in this region is the Dauki fault, Oldham fault. Now the question is, does the Oldham fault exist or not? There are some doubts about that. So basically, if it exists, and in my empty studies, I don't really see a strong fault here, but at the same time, the resistive structure is such that it can be a fault, it may not be. I'm not very sure. So what I did is, like before, I'll come to that later. And now here I'm comparing my structure, the geological structure, with different data. Now I think at the top you have all the large earthquakes in this northeastern region. Mostly I have obtained them from the NEIC website. The figure B, the second figure in the middle, shows the geoelectric structure which I obtained, and I have superposed them with the earthquake epicenters, micro earthquake studies conducted by Dr. Khatri and et al. I think 1992. And in the third, the figure C shows some of the fault plane solutions which are obtained by Dr. Kayal in this region. So effectively what I have done is, whatever seismic data is there available in this region, I have superposed all that data on my geoelectric section. And there may be a little bit of drafting error which can happen because of different draftsmen plotting the same thing. That thing is there. Otherwise, I've tried to do my best to sort of match the coordinates as far as possible. So now we will see that there is not much of a coordination between the deep earthquakes and the larger earthquakes, more than the magnitude 5 or 6, and the structure. Whereas the microseismic studies of Khatri in the figure B show that, and basically, as I told you, most of the data comparison in the northeast becomes a little sort of confusing because there is a lot of scattering in the data. I don't know whether you can see at the bottom part, can you see this I don't know whether you are seeing the arrow here. Can you see the arrow? The marker I'm moving? If you can see, the cluster of microseismic epicenter shows some alignment along the Dauki fault. Maybe it's there, maybe it's not there. And then as far as the Oldham thrust is concerned, which is supposed to be exposed somewhere here, there is a little bit of right dipping or say south dipping features seen in the earthquake epicenters. Although there is, and it's not very clear, the fault plane solutions don't really tell much except that maybe this line number 6 shows a little bit of coincidence with the Dauki fault. But otherwise, line number 8 is nearly vertical and line number 7 is horizontal. So I myself can't say much about whether the Oldham fault exists or not. Dauki fault, yes, I've clearly seen, so there's no doubt about that. Now, because of these difficulties in trying to compare the gravity, like gravity or seismics, they don't show much, like they don't show any major correspondence with my data. So what I did, and this was a suggestion by reference. So what he suggested is, why don't you do a gravity modeling and try to assign proper values, whichever representative values, and see whether you can reproduce the code. Since the gravity doesn't prove anything uniquely, you better try to see whether you can get the gravity. So this is one of the forward models I did with the gravity. Now you can see, and this is the basic native crust. The sediments, the lower Brahmaputra sediments are here. They're shown with a resistivity of around with a density of around 2.2 grams per cc, and they exist almost up to this station 17. Although their thickness is a little low this side. And this is almost 10 kilometers. This approximately 1 centimeter on this slide is around 10 kilometers, so you may not be able to see the sediments very clearly. But they exist up to station number 16 or 17. And then basically on the left side, you can see 2.57 and 2.5. These may be sort of compressed sediments which have sort of subducted along the Brahmaputra coast. And these are the 2.25. On the right side, you can see the block E. There is a sediment of 2.25